So we're going to be moving on through the vertebrate groups, still with the bony fish. It says, dang, that gives me the creeps. I wish he'd hurry up and scoop that guy out. Now, it is true that typically when aquarium fish, which are usually bony fish, die, they're floating, but they're also floating upside down like he's floating. That's because once they're dead, bacteria in their intestines start to, because they're not getting food anymore, they start to break down the tissues. The tissues are no longer separated from the inhabitants, the bacterial inhabitants, by mucus, because it's not making mucus anymore. They start to break the tissues down and generate waste gases. The gases balloon out the intestines. You'll see, a lot of animals swell up when they die, not just fish. And that's for the same reason, is that the intestine fills up with waste gases. And in this case, it flips them over because their intestines are ventral on a fish. So the coelacanth is a lobe-finned fish. And so they have these bases of their fins that have some bones in them. And this is a somewhat old overhead. The origin of the amphibians, which is the group we're about to do, they definitely originated in the bony fish. The question is, what type of bony fish gave rise to the amphibians? And the lobe-finned fish right now are not the leading candidates, but this is cyclical. I've seen the lungfish be candidates. I've seen regular bony fish with, remember the thing about the swim bladder being a lung derivative? I've seen that connection. Lobe-finned fish is a kind of obvious connection. There aren't really great fossils that put step by step by step in the line going. So tetrapods, 4 legs, land animals. Here's an early group, later group going off to the reptiles. Here's a split off going to the surviving amphibians. There's a very small, you can see this line is very thin, wormy group. Remember wormy shapes show up everywhere. Something called the Sicilians. Not spelled like the guys from Italy, though. And a lot of side groups that we'll talk about, at least up here, we'll talk about later. But this is the group that we're dealing with here. We're dealing with the amphibians. And I think because I've got a decent number of overheads and there isn't a lot to talk about, that I'm going to expect you to kind of write stuff down as I go, and I'm not going to write stuff on the overhead. These are considered the first terrestrial land-living vertebrate group, first backbone group on land. There's your 4 legs, tetrapods. There's your 4 legs. This is a terrible example of the amphibians. And there's the Sicilians, no legs. They've got a few characteristics. They can survive in the air. A lot of them have lungs, outgrowths of their digestive system that they can fill up with air, and oxygen gets into the blood, carbon dioxide goes out into the air, the breathing goes. Some of them have a lot of blood vessels under their skin, They do what's called cutaneous breathing, where the oxygen, carbon dioxide exchange happens across their skin. Your skin's, any kind of breathing surface has got to be wet, is that the oxygen and the carbon dioxide need to move through the membrane and then a little layer of wet to get out. So amphibians that use their skin for breathing definitely have to live someplace wet. Around here, if you turn over rocks in the right place or logs, used to be very, very common. They're much harder to find now than they used to. There's this kind of bronze-colored salamander with a little bit of a stripe up its back. Those are what they call lungless salamanders, and they do breathe totally through their skin, but they live under things because it's wet under there. This is a mud puppy. Mud puppies are a rarity in salamanders in that they live in the water their entire lifetimes. That's why they have these external gills, and they look like that through their... Now, they do live around here. They get fairly big. There are versions in China that get like this size. Supposed to not be the nicest animals in the world. You can pull them out of the Mohawk River. But typically, the salamanders and the newts, which is one of the groups, and the frogs and the toads, which is the other major group, are land animals. Some of them have gotten relatively successful in moving into somewhat dry areas. Not so much the salamanders, but the toads. If you ever handle a toad, if you grab a frog, they feel a little bit slimy because they tend to be moist. They dry out easily, so they tend to stay places where they can be wet. Whereas toads, pretty waterproof skin, and you handle them, they don't feel slimy. They may feel other things. I'll get back to that in a minute. When the plants got onto the land, big challenge that took them a long time to evolve their way past was the need for sperm to swim to where the egg cells were. Vertebrates had the same problem, and amphibians, for the most part, never solved this. Is that they reproduce with external fertilization. The females lay the eggs, and the male releases sperm where they can get to the eggs. And this generally requires open water. Sometimes, it could be a tiny little pool somewhere, but they need to go into the water to reproduce. Now, for the frogs, what hatches out of the eggs is a very fishy-looking tadpole, and the tadpole eventually transforms into a frog. It grows legs. It lives in the water for a while, has its own little niche in that ecosystem, develops legs, goes up on land where it becomes a land predator of insects and little animals mostly. So like the indirectly developing insects, the frogs and toads go through metamorphosis, where they have a larval form. They don't have a pupal form, but they have a larval form, and then they have an adult form. And those exist in different niches in the environment. So you've got your frogs and your toads in one major subgroup, and I'll put that overhead back up. And you've got the salamanders and newts in the other one. Salamanders are very lizardy in shape. They're not scaly though. Real lizards would be scaly, is that their skin is smooth. And the difference between salamanders and newts is newts do a weird thing where they start as a swimming form. That's what hatches from the eggs. They go up on land for a while, and then they go back into the water and live a decent amount of their adult life in the water. And they have flattened tails, and they're good swimmers. And that's where they reproduce. They don't have to go into the water to reproduce. They're already in the water when they find each other. Then they lay their eggs. Whereas most salamanders, their larval form looks like a little salamander. they come out of the water pretty quickly, and they live most of their adult lives, in fact, pretty much all their adult lives, in the air. But they do, when they're ready to reproduce, they do find open water the same way that frogs and toads have to. But they don't go through metamorphosis. Another common feature, and this has a lot to do with the fact that in order to stay moist, they have a lot of glands under their skin. They can secrete moisture onto their skin to keep themselves from drying out. A lot of them have supplemented that by being able to secrete some fairly nasty chemicals. And so these guys tend to be, the toads do, and a lot of the salamanders and the newts do, are somewhat toxic as a defense mechanism. Is if you used to have, you get toads in your lawn. If you have cats outside, the typical way that a cat plays with a toad is it goes up to it and it kind of sniffs it. And what the toad will do is it will bend its head down, and you can see it straining. What it's doing is it's squeezing its glands on its back and producing a fairly noxious, not hugely poisonous, but nasty smelling and nasty tasting chemical. And your typical cat playing with a toad, it looks like this. They kind of lean away so they don't have to smell it, and they kind of bat at it. I don't know what they do to clean that off later. Is that when I was a kid, my dog would occasionally find toads, and she would play with them by, she would grab them between two of her canine teeth like they were forceps, and she would very gently lift her head up and then toss them in the air, and then they would go, and then she'd go grab them again, very gently, and toss them in the air. Is that she didn't want to close her mouth on them because they were nasty, but she wanted to play with them. Did never eat them. Eventually, they just scurried away, hopped away. Weird feature of amphibians is they have huge mouths in relation to their heads. Big old mouth. Legs tend to splay out to the side, limits size to some extent. During their heyday, when they were the be-all and end-all of vertebrates, there were froggy type amphibians that were about the size of a Volkswagen Beetle, big animals. But because of their need for water for reproduction, they have tended to, over time, they got outcompeted, especially as the big animals. And they're fairly successful, but what's left are fairly small versions of the amphibians. And that covers another group of the vertebrates.